Hello, hermanos y hermanas. Let's do a mass calculation. Let's say that we started out with 0.4 grams of a magnesium ribbon, and the question would be, how many grams of magnesium oxide do we get in the end? Well, to do this, there are 3 bridges. One of them involves a formula weight. Another one involves a molar ratio. And then another one of the bridges involves a formula weight. And so remember, as we do a stoichiometric problem, that whatever we're trying to get rid of goes on the bottom, and what we want in the end has kind of got to be on the top. So what we want to do, if we start out with 0.4 grams of magnesium ribbon, which is pretty close to what we did in lab, or what I did whenever I did this experiment, we would say that 1 mole of magnesium is the same thing as 24.3 grams, wouldn't we, of magnesium. That allows grams of magnesium to cancel. Now remember, we're going to magnesium oxide, so when we look at the coefficients, we've got to put magnesium oxide on the top, and we're trying to get rid of magnesium, so that's got to go on the bottom. So we generate, in a balanced chemical equation, we generate 2 moles of magnesium oxide for every 2 moles of magnesium metal. That allows us to cancel moles of magnesium. And then the last thing we need to do is we just need to tell how many grams in 1 mole of magnesium oxide. So remember that we're trying to go for grams of magnesium oxide, so that goes in the top. So we say 40.3 grams of magnesium oxide is the same thing as 1 mole of magnesium oxide. That allows us to cancel that. So in our calculator, we're going to put 0.4 times 2 times 40.3. I would hit enter here, divided by 24.3, hit enter again, divided by 2, hit enter. And we should get an answer that's probably in the 6 or 7.6 or 0.7 range, something like that, I'm guessing, based on what we did in the lab. So let's see how this goes. Let's get this where you can see the numbers. We've cleared it out. Let's say 0.4 multiplied by 2 multiplied by 40.3. Okay, can you see that? And let's hit enter, and I've got 32.24 divided by 24.3, enter, divided by 2, enter. Yeah, we get about 0.66, 0.7. I probably should have said 0.41 so we could go to 2 sig figs, but let's just say it's 0.66 grams, or let's just say 0.7 grams. How about that? And that would help us to satisfy our sig figs. That is called a stoichiometric calculation, or a mass calculation. Wow, this is a fundamental skill that you will need all the way through Gen Chem 1 when you're working beast mode problems in the chapter 8 in the textbook, and when you're doing gas law problems. This is a gift that keeps on giving. If you learn how to do this, this will serve you well, and that's why I'm taking the time to show you how to do it. Be well. This is Brother Barnes.